binomial expansions now. So what we've learnt the last few weeks has been the opposite of expanding. We've been learning the opposite, which is called factorizing. Right? Today we're going to pretty much learn the opposite of factorizing, which is going to be called expanding. Now, expanding is actually pretty easy. There's nothing too overly complicated except one concept, which is perfect squares, where there's a formula. Otherwise, the rest of it is pretty straightforward. So factorizing is the one that's a bit harder. But let's learn how to do binomial expansion. So you'll have questions like this: 3x plus 2 multiplied by 6x minus 4. And the way to expand this is your first term multiplied by your first term of your second bracket. And then again, your first term here multiplied by the second term. And you just do the same thing again with the second number. So second number multiplied by the first term, second number multiplied by the second term. It's all about multiplying. So let's see. What is 3x multiplied by 6x? Jono, what's 3x times 6x?
18x.
Squared.
Yeah.
Don't forget, x times x is x squared. Perfect. Then again, what's 3x times negative 4?
Negative 12x.
Beautiful. What's 2 times 6x?
2 times 6x, 18x.
12x, you mean? That's fine. And then what's 2 times negative 4?
Negative 8.
Perfect. Easier than factorizing?
Yeah.
Yeah, I said so. So this one should be a walk in the park for a lot of us. Negative 12x plus 12x, it does simplify. In fact, they cancel out. So the only answer you have in this case is 18x squared minus 8. Jono, any questions? Nope.
No.
Nice and easy. Do you want to copy it down real quick? If you haven't already. Jono, moving on.
Oh, yeah.
Yep. Okay. Brody, you're going to do the next one, buddy. So be ready. It's going to move straight down to something like this. Question 19. Maybe it's a bit blurry. Can you read that, Brody?
Yeah.
Yep. All right. 4x squared multiplied by
3x.
3x, what? 12x to the power of 3 would work.
It would be
Then 4x squared multiplied by
1.
minus 1, which is? Sorry? I can't hear you, actually.
Hello?
You're too far from the mic.
Hello?
No, I can't hear you all of a sudden.
Hello?
Yes, that's better. Yep, so 4x squared times negative 1 is?
it will be 2.
Sorry?
See.
No, it's bad again.
Hello?
No, can't hear you. All right, hold on. Maybe just looking to see if you can fix up your mic for a sec. I'll get somebody else to help me out for the time being. Aya, 4x squared times -1.
Negative 4x squared.
Beautiful. And then again, 3 times 3x.
9x.
And then last one, 3 times -1.
Negative 3.
Is there anything here that are like terms that you can simplify?
No.
No. So that's it. That's your final answer. Any questions there? Nope. Anybody have any questions? Making sure. Okay. Let's go again. What's the next one? I'll leave that one for now. Difference of 2 squares. It's good, but you could just expand it however you want. Question 12, you don't even need to learn a new method. So go. You don't have to use difference of 2 squares. I probably prefer not to use it just yet. Just to see that you guys can just expand worst case scenario. So who's going to try this? Yeah, Angelina. Hi. Could you expand this for me? 6 minus 3v, 6 plus 3v.
6 times 6 is 36.
Perfect.
And 6 times 3v is 18v, and then 3v
Negative, be careful. Negative 3v times 6.
times 6, negative 18v, and then negative 3v times positive 3v is 9v. Negative 9v to the power 2.
Yeah, very important that it's you got to check the negatives and positives. And then anything here that can simplify?
The positive 18v and then negative 18v.
And the answer is
Yep.
easy.
Yep.
So why did I just do this exercise like this? I'm trying to show you guys, I don't think you even need to learn a new way to do expansions of difference of 2 squares. Yes, it's good to learn it and your teacher will teach it to you and that's fine. But for our sake, I'm not too worried about the expanding of difference of 2 squares. I'm more interested in learning to factorize these into this. So the expansion, I know worst case scenario, you guys would just expand. So I'm not too worried about that. Yeah. I'm going to move down and then we're done. Okay. So the only part that should be hard or different would be what's called a perfect square. Perfect square. And that's one we shouldn't have heard just yet. So a perfect square expansion, perfect squares. Perfect. I think that's a key word, right? Because everyone mixes it up between difference of 2 squares. It's perfectly, the whole thing is squared. The whole thing is perfectly squared. What perfect squares tell us is if I've got something that looks like this, so a plus b squared, I can actually expand it pretty quickly using a little formula. And that formula looks like this. A squared plus 2ab plus b squared. In other words, it's saying a squared, the first squared, the last squared, so first squared, last squared, twice, 2 times inside. So multiply the insides. So before I move on, do you guys understand what I've written there? First squared, last squared, 2 times the inside. Does that make sense? So Jono,
I don't.
you're going to tell me, does it make sense to you?
Yeah.
100%?
Yeah.
Say it again. Say this to me all out loud.
The first squared plus the 2 inside plus the last squared.
Okay. Does anyone not understand this? All right, let's see. So Jono then, x plus 2 squared. If I told you expand this. All right. What are you going to say? What's your little formula that you've just memorized? Jono?
Oh yeah, x squared
Okay, yep, x squared is correct.
plus
Plus,
2 squared.
okay, yes, you're doing the last squared first.
Yeah.
Yep, that's fine. So hold on, let me write that. We usually put that at the end. Yep, that's good. I can do that. I'm happy with that. So first x squared, 2 squared. So you got the first and the last ones out. Now,
X or 2x 2.
yeah, I'll accept that. It's 2 times 2x. We don't write x2, I guess,
Oh,
because it sounds like a car, right?
yeah.
So let's try it as 2 x's. Yeah, that's good. So you're just multiplying these two together. That's what the inside means.
Yeah.
And then let's simplify this. What's your final answer?
X squared plus 2x, 4x plus 2 squared. 2 squared.
No, come on.
2 cubed.
No, don't change. Don't do that. Simplify it.
1.
2 squared.
Oh,
2 squared. Relax.
4.
Oh, that's it. Don't just say 1 out of nowhere. There we go. Perfect. Yeah, Jono, make sense?
Yeah.
Yeah, cool. Good job. So the trickiest thing is just learning what I've just said there. So for a perfect square, the expansion is first one squared, second one or last one squared, and then 2 times the inside. So let's do it. Let's go slowly. Why rush? You guys are doing well. X plus 5 squared. Yusuf, tell me, have you done this at school yet?
No, I haven't.
Cool, go ahead.
X squared,
Mm-hmm.
and then you times the inside, so 2x and 10, 2x times 10, which is
Wait. Slowly. You said it all correct, but it was all jumbled up. So just one more time.
and
It's
then
2
times the
times,
inside.
which is 5x.
Yeah. Oh yeah.
And
5x.
then
And then 25 plus 25.
wait. What am I writing in the middle here?
So 5x.
No, it's 2 times the inside. So
So
the
10x.
inside is 5x.
Is it 10x?
That's it. You had said that before, but you didn't say it the second time around. 10x plus
25.
25. 2 times the inside. Good. Let's go again. X plus 3.
X.
Darius.
Oh,
Yeah, go ahead. No, Yusuf, go.
x squared,
Yep.
and then you times the inside, so x3, 2x, no, 3, 6x.
I'll help you because I think you'll get this. If you multiply these two together,
x3, no, 3x,
3x, that's good, and then just times it by 2.
6x.
Right? Or what I usually do is go 3 times 2. I look for my number, which is this one.
Yeah.
3 times 2 is 6, and then multiply it by this.
Oh, okay.
So if that helps, but that's fine. 6x plus
And then 9.
9. One more time then. You might as well finish it off. Yusuf, go.
Yeah, x squared
Yep.
plus 8x
Yes.
plus 16.
Beautiful. All right, write down what you need. Okay. Let's go a little bit higher now. X minus 5 squared. Okay, let's see who's going to put 2 and 2 together. Aya, what are you going to say? X minus 5 squared. What's your answer?
Remember x squared minus 10 x and x minus 25.
She is super close. She's realized one thing that students make wrong, but then she's got something else wrong. Can someone help us out where? I think Darius might know. But
Two negatives make a positive.
yeah. So you said x squared here. I agree with that. I also agree with this. So good job with that. Negative 5 times 2 is negative 10 times x is negative 10x. But what's negative 5 times negative 5? Positive 25. Does that make sense, Aya?
Yeah.
In fact-
Why is it not x squared plus 10x?
Because what's attached to the 5?
Negative.
Exactly. So what's negative 5 times x times 2?
Positive 10x.
How?
Oh wait,
Yeah.
no. Oh, I see. Yeah.
Yeah, it's negative. So I was just about to say the trick to it is your first and your last must always be positive. The middle just follows whatever this is. If that's negative, that's negative.
Okay.
Positive, it's positive. But your first and last must always be positive because you're squaring them. Okay, cool. Next. Let's try it again. Angelina, x minus 8 squared equals?
X squared minus 16x plus 64.
Yeah, awesome. One more time, Angelina, just to make sure. I'm going to take it one level higher than this now. 2x plus 3. Be careful, is all I'm going to say.
4x
But that's it. I think you're saying it. Sorry, go ahead.
squared
4x squared.
plus 12.
Wow. Yes.
Oh, sorry, plus 9.
Yeah. Good. Plus 9. Well done. 4x squared plus 12x plus 9. Anyone have any questions about what she's done there? She got it all correct.
Yeah. Where did you get 12x from?
Where did you get 12x from? 2 times 3 is
6.
times that by 2 as well.
Okay.
Do you know why we're timesing it by 2 as well?
Because there's.
Because the formula says times by 2 as well.
Alright.
right? So it's 2 times the inside. So the inside right now is 6x, and then times it by 2 is 12x.
Okay.
Angelina, have you done this at school before?
Yeah, I think something similar.
Cool. This year? Or last year? Angelina? This year or last year?
This year.
Nice. Okay. We'll go one level higher. 3x minus 4 squared. Open to anyone?
Oh, 9x squared
9x squared. Yep.
minus 24x
Yep.
plus 16.
Perfect. Have a look at that, guys. Tell me if there's any questions. No, no questions? Okay, I'll do one more of those. Jono, Brody. Brody, is your mic working now? Maybe? Can you try for a sec? Nah, something's wrong. Maybe can anyone else hear him? Or is it just me?
No, I can't hear him as well.
Yeah, okay, fair enough. Yeah, Brody, something's up with your mic, I think, buddy. Either you're too close or something's gone wrong. Jono, what about you?
Oh, yeah, all good.
Making all sense?
Yeah.
Jono, do the next one, just making sure, and then that's it. Then we'll go one level higher than this. 2x minus 5, I guess. There you go.
4x squared minus 20x plus 10 squared.
10 squared.
No. 25.
You did 5 squared as 5 times 2. So
Yeah.
5 squared is 5 times 5.
Ah, okay. Okay.
All right, good stuff. Let me see anything other than fractions left. Nope, just fractions. All right, next one. Next level higher. X on 3 plus 4 squared. What's the expansion to that?
X squared over 9,
Yeah.
and then plus a so plus no. So plus x over 9. No. Um uh Oh, can you do like can you put a 1 over the 4? So then you can
One.
multiply them?
1 over the 4 or 4 over 1, you mean?
Oh, 4 over 1 and then multiply them.
Yeah.
So it will become 36 over x squared. No, yeah.
Like
Yeah.
that.
Yeah, like that. And then 6 plus 16.
All right, your 16, I agree with. Your x squared on 9, I agree with. This 36 on x squared. I'm trying to understand what you've done, so give me a second. How? How'd you get? All right, tell me your process.
So I just thought that if I make the 4 a fraction as well.
I understand. But then what do you do? How'd you multiply them together to get 36?
I did 9 times 4 and 1 times x.
All right, hold on. Did you say 9 times 4? But isn't that 3?
Oh no, yeah, 3 times 4, so it's 12 over x squared.
And then how'd you get x squared?
Because we multiplied it,
Yeah, but x with what?
so it's 2x.
But you multiply x with what? X with
2.
2. Right. That's what you're saying you're doing. So you did this and then, yeah. Now you've done, you mixed up a lot of concepts in the one place. Yeah, no. Now that I understand what you've done, nope.
Yeah.
All good. It's a lot simpler than you might think. But you're multiplying it is incorrect. The way you've multiplied is wrong. Anyone? Anyone know what the middle should be? I'll give you a clue. 2 times inside. Not much of a clue.
Would it be?
Wait. Jono, you can go first.
Would it be 24?
Just
Well-
24?
24, yeah. Or 24 squared, which is 48.
No, 24 squared is not 48. You got to stop doing that. 24 squared means 24 times 24.
Oh, okay.
You got to stop
Well, then
doing
just 24.
but wait. No, it's not right. That's fine. Good try. I know what you've done. You had kind of the right idea, but no. And I'll tell you what you've done soon. I think Aya, you were going to go.
I got 24 too.
I got 24 too. I know what you both did then. You both did this. 2 times 4 times 3. Which is close, but you've made a mistake. A very bad mistake that you should remember for a very long time. You say it?
You should multiply 2 with 3 as well.
But they are. 2 times 3 is the same as 2 times 4. The order doesn't matter, does it? Like that is the same.
No, you should do 2 times 4 and then 2 times 3 and then multiply them.
Right. So you're saying they should have done 2 times 3 and then 2 times 4.
And then multiply them.
Have we done that ever before?
No, we have not.
Then don't ever change it. So
Okay.
what you're doing is you're changing what we've never done before. So don't do that. You're trying to always keep it as consistent as possible. That's one thing in math. Never change your method. Now they are close with this, but they're making a mistake.
Sam?
Yes, tell us.
Would it be, so you make 4 a fraction by doing 4 over 1,
Mm-hmm.
and then you
You
would
find the
times them.
reciprocal.
So you do,
Let him say it. What did you say, Darius?
you would times them. So you do 4x over 3, and then times that by 2, so 8x over 3.
That's better. See, the mistake you guys did here, Aya and Jono, you guys just looking at numbers. You didn't care about where the numbers are located, but that number, that 4 is in the numerator, whereas that 3 is not in the numerator. Where is that 3? It's in the denominator. So what number is this, Aya? What number is this whole thing?
X or 3.
Just the number.
3.
There's a number here, isn't there?
1.
Yeah, so what's the number? What's the whole number? Come on, Aya.
Isn't this 1 over 3? Which equals
There we go. 1 over 3. Perfect. Yeah, you said I didn't hear that if you say it. So instead of saying 2 times 4 times 3, it's meant to be 2 times 4 times 1 on 3. Does that make sense? Jono, does it make sense?
Kinda. Not really.
How can you say that a number that's in the numerator is going to be treated the same as a number on the denominator? If I came up to you and I said, "Hey, Jono, can you do 4 times a half for me?" You can't say, "Oh, Sam, that's just 4 times 2 is 8." What?
Okay.
How is that
Yeah.
allowed? Right?
Yeah.
You know that's not allowed. You know 4 times 2 is 8. How can
Yeah.
4 times a half also be 8? That doesn't make sense. Something's gone wrong. You can't just go and ignore the number on the top. And if you guys thought there was no number on the top, you have to remember in algebra, there's always an imaginary 1. So that number is actually a third. So when we're multiplying it, we're going 2 times 4 times a third. And what number would that be? Well, what's 2 times 4? 8. 8 times 1 is 8. 8 over 3. And then, of course, don't forget you've still got an x. So you're multiplying it by x. So technically that was an x on top. 8x on 3. Aya, what do you reckon? Make sense?
Yeah.
Very important that you follow through the fractions. Yusuf, does it make sense to you as well now?
Yeah, it does.
Let's try another one. A on B plus 2 squared. What's your answer?
A squared over B squared plus
A squared over B squared.
plus. Okay, so 4 over A. No, 4A
Ah, I like it. 4A.
4A over B
Yes.
plus 4.
So what he did there, he realized, hold on, A is in the numerator. B is in the denominator. I'm going to multiply it by 2, which is in the numerator. And then I'm going to multiply again by 2 because of 2 times the inside. And if these are all in the numerators, because obviously, they don't have denominators, 2 times 2 is 4. 4 times A is 4A divided by B. Well done, Yusuf. That was pretty quick. Let's try another one. Anyway, anyone not understand that one as you're looking at it now? No? No questions there? Okay, let's try another one.
Sam.
Yep.
So it'll be 9x squared over 4 minus 24x over 2 plus 16.
You're not wrong, but because I know you have to simplify, I'm just
Oh,
going to
yeah.
simplify for you. But well done. First one squared. He just did 4 times 3 is 12. Then he multiplied that by 2, 24. X still divided by 2 plus 16. And then I just told him that in this case actually simplifies. Any questions there? Good. Last one. Let's go really the hardest one you could get. Let me think. I don't even know what's the hardest one you can get. Up to I guess a year 10 level. Up to a year 10 level. What would be the hardest you can get up to a year 10 level? Hardest up to year 10 level. Doesn't really get much harder. They're all the same straightforward stuff. Hardest you can get in year 10. Up to year 10, year 11, year 11, year 11, year 11. Year 11. Year 11. Maybe we'll just introduce some powers. So 3x squared on 4y minus minus 2y on 5 squared. All right, let's see if I can get anyone from that. But that, look, I've never seen it in an exam. It's just to see if you know, if you really get it, then you'll probably get this out fully.
Sam,
Yeah,
can I say the answer?
yeah, good luck.
9x to the power of 4
9x to the power of 4. Yep.
over 16y squared
Over 16y squared. Yes.
minus
Minus
12x squared y over 4 over over 20y plus 4y squared over 25.
Wow. I actually think you got it all out. 9x4 over 16. Yep. 2 times the inside. So he did 3 times 2 is 6. Times it by 2, he got 12. Then x squared, y, just put them together. Over 4 times 5 is 20y. Done. This is 2 squared, 4y squared over 25. Yeah, perfect. The only thing, obviously, you haven't done yet, but it's fine, is just simplify. 12 over 20, you can divide them both by 4. So that becomes -3 on 5, x squared, and then the y's would cancel out. And that's it. That's the actual final answer.
Sam,
Yeah.
how come you minus the top twice and you minus the bottom? Sorry, you multiplied the top twice and you multiplied the bottom once.
Are you trying to say why did I times the top by 2, but I didn't times the bottom by 2?
No, so you did he did 3 times 2, which is 6, and then you multiplied it by 2 again.
Because that's the
12.
formula, right?
And then you did the bottom 4 times 5 once. Wait.
Yeah. So the formula is 2 times the inside, right? When we say that, it's just there's only the 1, 2. Just the 1, 2. Now, if you're multiplying something by 2, do you multiply the top or the bottom by 2?
The top.
Yeah, exactly. That's why it's 12. Does that make sense? So 3 times 2 is 6, times 2, because of the formula, becomes 12.
Oh, okay.
You get that? At the bottom, it's just 4 times 5.
Oh, okay.
Are you sure you understand?
Yeah.
Okay. Okay. I'll stop that recording.